Hi students, this video is on chemical and physical properties. In this video, you'll learn that there is a difference between a chemical and a physical property, and we'll be able to identify what those differences are. By the way, I'm also using the subtitle feature down here for my recording program, and we'll see how it goes. If it's just distracting and doesn't work well, I might not use it again. If it's helpful, leave me some feedback and let me know that that was helpful. I'm not gonna, look at it too much. It's basically just listening and predicting what I'm saying. So I'm not typing this up. But if it helps, then we'll keep it. The second goal is to identify the different macroscopic. So remember, that means the big, like the things that you can see with your eyes, your senses, macroscopic properties of matter, and then categorize them as physical properties or chemical properties. So we'll be able to tell the difference between those things. Okay, so you live in California, and living in California has some benefits. We don't get extreme temperatures, but one of the downsides is that some of the common kinds of examples that we'll use in science class doesn't really translate because we don't, as Californians, we don't really get extreme temperatures. But something that happens, we occasionally get freezing temperatures, and something that happens very often in really cold climates, especially like the Midwest or the Northeast, even the Pacific Northwest, you can get freezing temperatures at night. And when those freezing temperatures just get super, super cold, the pipes that are in your house can freeze, meaning the water in the pipes will freeze. And when that happens, often people will experience a burst pipe. And this can happen sometimes, especially if people have like a house that is like a winter house, and they leave their house there for the winter, and no one's actively using water, and then it freezes overnight. Well, these pipes burst, and obviously that causes problems because water will leak out of the pipe. It's meant to carry water to like your toilet and your sink and everything, so that water will leak out. And this is a video done by Steve Spangler, who does a lot of science experiments. And one of the things that he's showing here isn't just a copper pipe, but a half-inch galvanized steel pipe. This is very, very, very strong pipe. And this is actually not typical for most household plumbing, but you can see even in this case when he's put it in very cold liquid nitrogen, just to get it to freeze quickly, the water that was inside this pipe froze, and as it froze, it basically explodes the pipe. And so the question is, why do pipes burst in the wintertime? Something, again, we're not really experiencing in California, but something that people experience all over the world. And it's a property of water, which you've probably noticed before. Maybe if you've put a water bottle in the freezer or something like that, you'll notice that water expands when it freezes. And that's an interesting property of matter, and in this case of water. And water is a component of matter. And so when we think of properties of matter, this counts. This counts as a property, a thing that water does. It expands when it freezes. So why does that happen? Well, water freezes at 0 degrees Celsius. That's a property of water, that it freezes at 0 degrees Celsius. And it also expands when it freezes. Now, what does that mean when it expands? That means that it gets larger, even though you're not adding any more mass to that water. So the water actually gets, when it turns into ice, gets larger than when it was in liquid form. So it expands when it freezes. And what that means is, because it's the same amount of mass, if you think about the density equation, if you remember this, density is mass over volume. The mass is the same, but the volume has increased, has gone up. So if the volume has increased, that's supposed to be an up arrow, sorry. If the volume has increased and the mass has stayed the same, well, the density is going to decrease, is going to go down. So as the density decreases, it gets bigger because it's taking up more space, but it doesn't weigh anymore. It doesn't weigh any more than it did before. So This is weird though, because water breaks the rules of almost every other substance. Other substances increase their density when they become a solid. And if you remember, the way that we talked about substances that are solids is that they have these little particles that do not move very much, and they're sort of stacked in this ordered fashion. This is when we learned about solids, liquids, and gases, the states of matter. And solids are this very kind of compact unit. Liquids they move around a little bit more, and gases are really far spread apart. And the reason is because the molecular movement is higher in gases than it is in liquids than it is in solids. And that has to do with temperature differences, but it also has to do with a property of the substance. Each substance has its own property that basically determines where it will freeze, become a solid, melt, become a liquid, and evaporate, become a gas. These are properties of matter. So you're looking at two properties here with water. That water freezes at 0 degrees Celsius. That's its freezing point. And you're looking at its density change. That's another property of matter, that of water, is that when it freezes, it actually increases its density, increases its volume, and so decreases its density rather than increases. And this is sort of a weird quirk of water, a property, we might say. So what are we talking about all this for? We're trying to determine the difference between what we call physical properties and what we call a chemical property. These are two different properties that every piece of matter has. This pen that's made out of plastic, my cotton shirt, this coffee cup, whatever I have, it has chemistry to it because it's made out of matter, and we can say that those substances have their own physical properties and chemical properties. And it's important to enumerate what those are so that we can use them for other things. So what is a physical property anyway? Well, a physical property is something we can describe about a substance when that substance does not change its identity when we do something to it. So for the example of water, when we froze it, it's still water after freezing it. And when we turn it back into a liquid, it would still be water after that. So we're not changing the molecule or the chemical when we do these actions. And we'd say that, the freezing or the melting, that's a property of water because we're not changing anything about it. Now, this is different from a chemical property because a chemical property, we actually do have to change the substance in order to examine this property. And there's a related concept here. These sort of seem like weird ways of defining something. There's something called a physical change and a chemical change. And you might be able to make this connection that a physical change would be changing its state, right? A state change going from solid to liquid or liquid to solid or whatever you're doing with its state would be a physical change because you're changing a physical property of that substance. Now, a chemical property is when we do change it. And in this case, I'll give you some examples, but you're basically using that in a reaction. And we want to know, well, how does this chemical react with other things? And those are its chemical properties. And in order to examine them, you have to actually change or alter or, make this chemical participate in a reaction during this process. One other thing that can be easy to help distinguish physical from chemical is that a physical property can be observed with the senses. So the five senses of smell, taste, touch probably don't taste. It's not good to taste many things in the chemical lab, but it still would change its taste. But sight, smell, taste, touch, and hearing. Those are all things that you can observe with the senses. And so we would say that those are physical properties if you can observe them. Now, there are some chemical properties that you can kind of observe with your senses, like bubbling, for instance. If you put, a tablet into water, like a Alka-Seltzer tablet or something, you might see that Alka-Seltzer tablet bubbles, and that's a chemical property of mixing those two things together. So you can see chemical properties sometimes, but what we're doing when we see that is that it's indicating how a substance reacts with other chemicals. So I don't mean that to be completely confusing or like saying that only things that can be observed with the senses are physical properties, but that does usually help distinguish it. And let's give some examples here. So one example is just temperature. If I'm going to change its temperature, I can, observe that with my senses. I can feel it, see that it's changing its heat, and that the temperature is going up or going down. So long as I don't burn it. If I, heat up wood enough, it will combust and turn into carbon and carbon dioxide. So, and actually water as well. So if I change the temperature too much, I actually might begin to observe a chemical property. But if I just alter the temperature, can bring it up, bring it back down, that counts. Changing the state of matter, kind of similar. Changing or examining something's mass. I can add more mass or take mass away, or I can just observe what mass it has. That is observing its physical property. And then another concept, might sound a little confusing, but solubility. This is basically just, can I dissolve it into something else? It's a little confusing because sometimes people may think that dissolving a substance into another substance actually changes the substance itself. Like if you take salt and put it into water, it's dissolved. But we actually know that that doesn't change the substance. It's a physical property to dissolve salt into water, because if you evaporate the water, what's left behind? Salt is left behind. So you can get that back, and that means that you haven't changed anything. So that's one way of remembering the difference between physical and chemical is, are you really changing anything about the substance, or can you get that substance back afterwards? Let's look at some examples of chemical properties. Some examples are flammability. Can you burn it? Okay, so if something can be burned, I'm going to draw some fire here. If something can be burned, then it is a chemical property of that substance that, you can light it on fire, for instance. You can't do that to water, right? So that you can see how some substances won't burn because they don't do that. That's part of their chemical nature. Rusting. So if something undergoes rusting, this is the particular chemical equation that usually you can say is occurring when rusting happens, but not everything rusts. So rusting is certainly a chemical property. And another one is reacting with an acid. You can also say reacting with a base, but reacting with a substance, and in particular an acid, is a good way to test if it has a particular chemical nature. So those are all different ways that you can, categorize things as chemical or physical. So let's think back to the bursting pipe. Which properties are responsible for that phenomenon? Well, we changed its density. Now, the density increased when we froze it. Density itself is a physical property of matter. It describes its physical nature. It doesn't describe how it reacts with something. It's describing when you look at it, you're not going to be changing its chemical nature. So density is a physical property of a substance, and changing that was a physical change. And we observed its freezing point. When we brought it down to 0 degrees, it expanded and it froze in the process. And when we're observing that, we're just changing its physical state, but it's still water. So overall, those are physical properties, and neither really could be what we call a chemical property, because move my face over here. Because when water is looked at in this process, we're not altering its chemical substance. We're not changing water from H2O to something like hydrogen gas. H2O becoming hydrogen gas and oxygen gas is actually a reaction that happens. You can make that occur actually just by putting a battery into water. You can cause that reaction to occur. This would be a chemical change, but we're not doing that here. We're just freezing it. Okay, well, that's the difference between a chemical property and a physical property. I hope that's helpful.